We have been working on microplastics for the past few years, and we work on a pretty broad scope project. It's not just one, we have multiple. Some of the projects, they are all focusing on microplastics, but different aspects of that. I would say probably we summarize our project into three main goals. One is we try to develop a scientific method that is convenient but robust for measuring very small plastics in the environment. And then the second goal is we want to actually understand how plastics weather or degrade in the environment. And the third goal is actually a more technical aspect. It's actually looking into chemicals embedded in plastics. It's called additives. People, generally speaking, when they think about plastic problem, they think about polymer itself. They are not realize that typically plastics they are loaded with lots of other chemicals, and those chemicals can get leach into the environment easier than the polymer itself. So that's so-called the additive aspect of plastics.
There are multiple projects that I work on, but specifically about microplastics. It's a very interesting project. When Dr. Yan spoke to me about it, she was also relatively new to it. So we decided to plunge into literature to understand more about what microplastics are, what do they do. Within the first day of research, it really blew my mind as to how much just washing my clothes is contributing to microplastic pollution. So that's when I decided that this is going to be interesting because it's a new topic in the sense that it's been around, but it's more recently researched. So it would be a nascent field. It would be great to have a good contribution to it in terms of research. And yes, to understand microplastics, not just literature, in general, a lot of information is seeming to surface now. And it all relates to how much the industry doesn't exactly have control over the plastics that we produce. And the onus just can't be on consumers. It's partly the industry and the consumers. And I think that's where we scientific researchers come in between to say, like, hey, this is what the producers are doing. Let the consumers know more about it. And then we can backtrack and see what solutions we can have. Because as Dr. Yan had already mentioned, once they're out in the environment, once they leak into the environment, there's nothing, it's irreversible, you can't control it. And micro, in the name itself, suggesting how small they are, you're not going to be able to see it with your eyes. So there's no way you're going to be able to control something that you can't even see.
So additives are something that people or public are less aware about. In general, plastics are always having a few categories of additives. Each category, they can have actually a pretty complex formulation. One is antioxidants. So this is required when the manufacturer processing the plastic and make into the shape that, or make into the quality they want in the products. The second kind is called UV stabilizers. This is to ensure the plastic will maintain its quality during the useful life of it. And imagine that water bottle, right? It'd be sitting on shelf for probably more than a year. So you want to make sure that bottle will not go hazy during that period of time.
Microplastics aren't necessarily new. We are learning newly about them, is how I would put it. So it's always the case that whenever something is new in science, like plastic comes as a byproduct of oil, and so, hey, we've been using a lot of it. And once you come to a point and you realize that, okay, what are the consequences of it? Because everyone knows about the Pacific dump, the Atlantic dump of plastics that's generally present. So then the question came as to what exactly happens to them once they're in the environment. And once they're in the environment, they continue to break down because you can't control what really happens to them once they're in the environment. You're not observing them every day. So interestingly, once they start breaking down, they can actually end up clogging up the river and oceans. And specifically, they can end up being in the digestive tracts of animals that live in the ocean, fish or any other species, and they can slowly accumulate, and then you end up consuming it because we all consume different kinds of food, and that could be one of the reasons why microplastics is gaining more importance now, because we're trying to understand the health implications it has on humans. Recent research has even shown that even newborn baby has microplastics. So there's none of us that are free from microplastics. Even the cleanest of air that you probably think is in the Alps has been tested positive for microplastics.
What is new is we start to understand this problem is very pervasive. It's not just in ocean environment. It's in fact, plastic can be found in any particular component of environment. Think about, for example, polar ice, human body, right? And so it's actually, we realize this is a universal problem.
Microplastics are very harmful. They can affect wildlife. They can affect like the growth of like the plants, trees, and populations around us. And also they can end up like in the food that you eat. So you're basically kind of absorbing like the microplastics just little by little by little, depending on like what you consume, and also the air that you breathe, because just from the breaking down of microplastics, they can sometimes end up in the air, and we can like breathe in that oxygen.
Detection of plastics could be a very challenging problem depending on what kind of samples you're looking at. Imagine it's relatively simple if it's just in water. We can use filtration to actually isolate those plastic pieces. But what if it's in soil, in sediment, right? You have majority, 99.9% are just benign material, this natural ingredient in the nature. And then you have tiny, it's basically looking for needle in hay. And so that becomes really difficult. And that is what exactly we are working on. We don't directly talk to plastic industry. We are researchers. There is a disconnect between us and the people who generate plastics. And there, a lot of times we thought about how we can get our message across to people so that they would consider, oh, this is what chemical, the ingredient of it would actually make the plastic life much longer or shorter. I think one way is through public. If we talk to public like this and we bring up the awareness and we make people more informed, the public has tremendous influence on the manufacturers, right? I think that in this country, on pretty much the rest of the world, the producers, they are responding to the consumers rather than the scientific community, the narrow community of researchers. I think other than, trying to give public this idea of why we should try not to litter on the beaches, it also kind of gives them the idea. When they next time buy products, they probably have more informed choices. They would select certain things over others. And those messages will get to send back to the plastic industry.
So people think about, okay, studying environment is just plant trees and save earth, but it's not like that. Like whatever we throw the waste, we are throwing the waste. Actually, we are causing harm to an environment. Let's think about recycling. So people is like, okay, recycling is like what the industry will take the waste and they will just treat and recycle. Recycling doesn't help like that way. There are so many factors where you have to think about, what kind of plastic it is, what material it is used, is it hazardous or not, and several factors, yeah.
I want people in Low to know that they actually have an interesting role in the microplastic problem. They can actually influence in multiple ways. For example, most of the time we know that the plastic end up in ocean, they come from land-based sources. So basically, urban areas close to the ocean. So those plastics, if they don't actually get disposed of properly, get to, the wind will blow it into waterways, and then the river will eventually carry them into ocean. So Low is being a major city close to the Northeast Shore. I think people there definitely, you have, I'm not saying you're contributing, but you have a role to make the waterway actually cleaner so that there is less leakage of plastic from land to to ocean. On the other hand side, I think people here, we all appreciate this very beautiful ocean environment here. We enjoy going to the beach in the summer. So I would say that this is actually, when we have ocean plastic problem, they can actually carry away in long distances. So we are not necessarily the polluters, but when contamination gets to a very severe degree, it impacts the entire coastline, including for example, the shore areas, the North Shore, where many people go to, and spend your summer. So I think the people in Lowell are both the recipient of this plastic pollution effect, but we sort of, in some ways, we could be the contributor of the problem as well.
Each plastic takes its own time. There are some today that they're saying microbes are able to degrade. Some that is not even possible. So if they're short chain ones like polyethylene, then good luck. Like they could exist for longer than you and me put together. And just to be on the funnier side of things, like I remember watching one of the George Carlin episodes on plastic, and he was like, maybe the earth just wanted plastic and none of us. So plastics are probably going to remain way more than we are going to. So despite now, for keeping the jokes apart, the truth is it's very hard to say how long each plastic is going to take. Depending on the type of plastic, it could be anywhere from 100 to 1,000 years. Yeah. So once they're in the system, they're pretty much in the system.
The environmental engineering program at UML is actually a relatively new engineering program. It was established in 2018, and it's part of the Civil and Environmental Engineering Department. Students in this program, we mainly learn about technologies and science that can help us mitigate pollution problems. So, for example, we're talking about treating water, treating water for drinking water purposes, or treating wastewater so that they can be safely returned back to the environment. And we also look at hazardous waste problem. That includes the existing hazardous waste generated by the industries, also a lot of the legacy problem. Think about, for example, here we have a lot of, in this part of the country, we had a lot of industrial activities in the past that polluted the land. And this requires extensive effort to clean up the site. We call that remediation. And we're also working on new problems such as emerging contaminants like plastics. We also work very actively with other academic programs. For example, the plastic project, we have great collaborators from plastic engineering department. They gave us a lot of resources and also share their knowledge on that. So I would say environmental engineering program is new, it's relatively small, but it touches on many aspects of environmental management and pollution mitigation that actually would impact every aspect of our normal daily life.
I'm from Lowell. I was born and raised here, and I went to Lowell High also, and then I transferred over to UMass Lowell. But I also went to Middlesex Community College, which is also in Lowell. Environmental engineering kind of fell into my lap as a major. I picked it at Middlesex Community College because it was the closest thing to architecture. And then once I transferred over to UMass Lowell, they were like, you have to pick either civil or environmental. And honestly, I was just like, I want to help the environment, so environmental. I didn't realize how much chemistry and physics was into it, and also like how harmful some of the things that are present in our everyday lives are, because there's a lot that is just very surprising, like PFAS and microplastics. Like, it's just kind of crazy when you really like understand like the gravity of the situation, and then you are studying it, but you can't really like do too much about it just yet because you're just learning about it.